Good day, viewers. You are welcome to this channel. In this class, we want to continue from where we stopped the solution to the 2023 mathematics WAEC question. So from number 31, the question says, find the value of alpha in the equation cos alpha plus 14 degrees equals to sine 4 alpha plus 6 degrees. So from this question, what we are given is cos alpha plus 14 degrees is equals to sine 4 alpha plus 6 degrees. So we want to solve this one now. We apply the property of complementary angles in a right angle triangle. This angle alpha plus 14, when we add it to 4 alpha plus 6, it must be equal to 90 degrees. So that means alpha plus 14 degrees plus 4 alpha plus 6 must sum up to 90 degrees. And by the time we solve this, we can add the like terms on this side. Alpha and 4 alpha, we can add it together. That will give us 5 alpha, then plus 14 plus 6, that's 20, equals to 90. So by the time we collect the like terms, take 20 to the other side. That means 5 alpha will give us 90 minus 20, which is 70. Then we can now say that our alpha will be equal to 70 divided by 5. That's divided both sides by 5. That means alpha will now be equal to 14. So, therefore, from this particular question number 31, the correct option is option A, which is 14. And question number 32 says, a bag contains 4 white marbles and 3 blue marbles. Another bag contains 5 red and 6 blue marbles. If a marble is picked at random from each bag, find the probability that they are of the same color. Now, when you look at this, from here, the marble that are of the same color are blue and blue. So from the first bag, we have 3 blue balls, and the total ball inside that bag was, is given as 7 balls. That's 3 blue out of 7. And in the second bag, we have 6 blue. So 6 blue out of the total of, in that bag, the total of the ball there is 11. So that's 5 red, 6 blue. So we have 6 blue out of 11. So the price of picking ball of the same color can now be given as 3 over 7 times 6 over 11. And from here, when you multiply, you'll be able to see directly from here that this will be equal to 18 over 77. So the correct option for number 32 is option B. Is 115 degrees. Find the area of the sector. From this question now, we are given radius R to be 3.4 centimeter, and we are given theta, that's angle, to be 115 degrees, and pi is given to be 22 over 7, and we have to find the area. Area of a sector A is given as theta over 360 degrees times pi r squared. This is formula to get the area of a sector. Then by the time we put it there, theta is 115. So we cannot say that area will now be equal to theta, which is 115 degrees, over 360 degrees, then times pi is 22/7, and we are given r to be 3.4, that's r squared will now be 3.4, that's 3.4 times 3.4, and by the time we simplify this expression here with our calculator, multiply and divide, and the correct option will be 11.6 centimeters square. So the correct option from number 33 is option B. Says the diagonals of a rhombus are 16 centimeter and 12 centimeter. Find the length of the side. This question on rhombus, we need to know the property of a rhombus, that when we have a rhombus, all the sides of a rhombus are equal. So it has four sides equal in length, and the diagonals bisect each other. So it has two diagonals that bisect each other at right angle. So diagonal bisect each other at right angle. Four sides are equal in length. Diagonal bisect each other. That means diagonal divide each other. And what we are given here is that it has diagonal of 16 centimeter and 12 centimeter. So if each of them bisect, that means 16 divided by 2, that will be 8. So assuming this diagonal here is 16, then here will be 8, here will be 8, that's bisected into 2. And the other one is 6, so we have 6, making 12. Then when we solve this one using Pythagoras theorem, because we can bring any of the right angle, we have 4 similar right angle triangle here. Then when we bring any one of it out, like, and we can get this one, applying Pythagoras theorem, and say x squared will be equals to 8 squared plus 6 squared. That's Pythagoras theorem, and that's x squared equals to 64 plus 36, and that sums to 100. That means to get x, take the square root of 100, that's square root of both sides. Square root of 100 there will give us 10. So that means s equals to 10 centimeter. And the correct option there is option B from question number 34. So question number 35 says the angle of elevation of the top of a vertical building from a point Z on the ground is 50 degrees. If the height of the building is 124 meters, find the distance from Z to the foot of the building. When we draw this diagram, you'll be able to see what they are talking about. They talk about a vertical building. So we have a building, and the building will stand on the ground. So they said from a point Z on the ground. This is point Z on the ground, and this is the top of the building, and the angle of elevation of that top from Z is given, and this angle now is given to be 50 degrees. That's angle of elevation, and this will be angle 90 degrees, angle between the vertical and the horizontal. And the question has said, find the distance from Z to the foot of the building. So this here is the foot of the building. We call it F. So we are finding distance ZF from this diagram. Then when you look at the question they gave us, the height of the building is given to be 124 meters. They say if the height of the building, so here is 124 meter. And solving this right angle triangle, we are finding distance ZF. That's the foot of the building to point Z. So we are using tan here, tan, because we know the opposite and we are finding adjacent. We know opposite, we are finding adjacent. That means tan 50 degree. From here, we can say tan 50 degree equals to opposite. And opposite here is 124 over adjacent, which is ZF. And by the time we make ZF the subject, we can say ZF, that's distance from Z to the foot of the building, will now be equals to 124 meter over tan 50. And we can simplify this one using our calculator. Finding tan 50, then divide 124 by that, and that will give us 104.05 meter. So that's the correct option for number 35 question. So question number 36 says, a student measured the height of a pole as 5.98 meter, which is less than the actual length. If the percentage error is 5%, find correct to 2 decimal places the actual height of the pole. From here now, percentage error formula. Percentage error is given as error. Percentage error is given as error over the actual length. Actual length, then times 100%. And from this question now, they give us the measurement of the student, and which is less than the actual length. So the error will be actual. If the actual length is x, we can say x will now be, that will be x minus what the student measure now, which is 5.98, then over the actual, which is x, then times 100%, times 100%, and here the percentage error has been given from the question to be 5%, so 5%. So both side percentage we dropped, that's why percentage is not put in this 5 again, so the percentage is not here. So we drop the percentage, and by the time we solve this particular equation, 100 here we multiply both x and minus 5.98, and x here we multiply 5 when we cross multiply, and that will be 5x equals to, use 100 to open that, so that will give us 100x, then minus, when 100 multiply this, we just shift the point 2 times, and that's same thing as 598. That's 598. And when we solve this, we can take this 100 to this side, and 5x minus 100x, that will give us minus 95x. So when we take 100x to the left hand side, it has become minus. That's 5x minus 100x. That's minus 95x equals to minus 598. And minus can drop each other there. So divide both sides by 95. We now have x equals to 598 divided by 95. And when we play this with our calculator, what we have will be 6.29 meter. 6.29 meter. So that is how to solve this. So the correct option there is option C. From 37 of the WAEC question says, in the diagram, O is the center of the circle. We are given this diagram and the said angle is given as 28. Find angle ORS. So we are finding angle ORS here. And you must know the angle you are finding first. That's the first thing. So angle ORS, it connects from O, passing through R and joining to X. So this angle in the middle is called angle ORS. So that's the angle we are finding. And how do we get that angle? From what is given here. From circle theorem, theorem 1, angle at the center is twice the angle at the circumference. So this angle at the center here is twice that angle at the circumference. So angle SOR here now, angle SOR, that's the interior angle, SOR, will give us 28 times 2, and 28 times 2 will give us 56 degrees. So multiply 28 by 2, we get 56 degrees. And from there, we can get this angle here now by following the property of triangle SOR. SO is a radius, OR is also a radius. So we have an isosceles triangle there because two sides are equal. Two sides of that triangle are equal, so we call that triangle isosceles triangle. And if it's an isosceles triangle, that means the base angle are equal. So the angle ORS and the angle OSR are equal. And when we call each of them X, we can label each of them as X. And remember, this is already 56 degrees. So by the time we add this 56 degree here, when we add 56 degree plus X, it must sum up to angle in a triangle. So X plus S is 2X, so we can say 2X plus 56 degrees will now give us 180 degrees. That's sum of angles in a triangle. And when you collect the like terms from there, that's 2X will be equals to 180 degrees minus 56 degrees. And when you subtract that from that, it will give us 124 degrees. And when we divide both sides by 2, X will now give us 62 degrees. So from here now, the correct option here is option B. And question 38 says, John was facing south 35 degrees east. If he turned 90 degrees in the anti-clockwise direction, find its new direction. Now we first draw the diagram. We have the 4 major cardinal points as given like this. We have this direction as the north. So see, this is north. We have this direction as south. We have this direction as west. And we have this direction as east. And the question says, John was facing south 35 degrees east. So southeast is here. And that angle 35 degrees will be measured from the south. So this angle is 35 degrees now. And we can get the remaining angle here. Because in between south and east, the total angle there is 90 degrees. And when we take 35 from 90 degrees now, this angle will be 55 degrees. So we have 55 degrees. Now, the question now says something here. If it turns 90 degrees in the anti-clockwise direction, you must know the meaning of anti-clockwise direction. When your clock is moving, this is clockwise direction. This arrow like this, clockwise direction. And when it's moving backward, this is called anti-clockwise direction. So from here now, we can, John was here, and when he now turned, back he was here before at the first place. So when he turned back in an anti-clockwise direction and moved angle 90 degrees in anti-clockwise, his new direction will now be, because from here now John is turning, he has covered 55 degrees, and when he turns furthermore, the total turning must be 90 degrees. The total turning to this place must be 90 degrees. And when you have already have 55 degrees, what remains to be added there to get the turning of 90 degrees will be 35 degrees. So that means here now he has turned in an anti-clockwise direction and he has moved angle 90 degrees, because formerly he was here, John was here. Then when he moved in an anti-clockwise direction. 55 was here. Then we add 35. That make it 90 degrees. And they now say find his new direction. His new direction is in between north and east here. So, of course, it will be northeast. So, the option will be between option A and... Okay, in fact, you don't even need anything again. Because from here now, it's only between northeast. And when you look at option A, that's northeast. Option B, southeast, out of the way. Option C, southwest, out of the way. Option D, northwest, out of the way. So, and when you look it perfectly now, this angle as well can be gotten by subtracting 35 from 90, also 55. That means John is now in the direction of north, 55 degrees east. So the correct option for number 38 is option A. And question number 39 says, if 2x minus 3y equals to minus 11 and 3x plus 2y equals to 3, evaluate y minus x squared. Here is a simultaneous equation. So we have 2x minus 3y equals to minus 11. Let's call this equation 1. And we have 3x plus 2y equals to 3. Let's call this equation 2. So we now choose a method that is convenient to solve this one. Here, I can use elimination method, and if I want to eliminate a variable, the coefficient of that variable must have the same number. So in order to make the coefficient of x here to be the same, I can multiply equation 1 by 3. I can multiply equation 1 by 3. Why? Multiply equation 1 by the coefficient of x in equation 2. So equation 1 will now become 6x minus 9y equals to minus 33. We multiply through by 3, and let's call that equation 3. Then also we can multiply equation 2 by 2, that is by the coefficient of x in equation 1, and equation 2 will now become, when we multiply through by 2, equation 2 will become 6x plus 4y equals to 6, because we multiply through by 2, and that's equation 4. Let's call that equation 4. And by the time we now solve equation 3 and 4 now, by eliminating x, we can subtract, and when we subtract, this equation 3, this equation 4, I want to subtract from here now. 6x minus 6x gone. Then minus 9y minus plus 4y. That's still minus 9y minus 4y. That will give us minus 13y. Then equals to minus 33 minus 6. Minus 33 minus 6. That will give us minus 39. And to get y, we need to divide both sides by minus 13. that's coefficient of y. Y will now be equals to 3. That's minus 39 over minus 13. That's 3. Then to get x, substitute y equals to 3 in equation 1. We can choose any equation here, but I want to use equation 1 here. So equation 1 can now become 2x minus 3y, and y is now 3. That's minus 3 times 3 equals to minus 11. And by the time we solve this, that's 2x minus 9 equals to minus 11. And by the time we bring minus 9 to the other side, that will be 2x equals to minus 11 plus 9. And that will give us 2x equals to minus 2. To get x, divide both sides by 2. That means x equals to minus 1. So we have y to be 3 and x to be minus 1. And the question says we should evaluate y minus x squared. So y minus x squared now will give us y is 3. That's 3 minus x is also minus 1. That's minus 1. Then square. So because we already have a minus here and our x is also containing minus, should be careful here not to make mistake in this kind of thing. And we now have plus here now. Minus here will give us plus. And that's 3 plus 1. And that's 4. So that's 4 square. And 4 square will give us 16. So the correct option for number 39 is option C, which is 6. So question number 40 says an equilateral triangle has side 2 cm. Calculate the height of the triangle. From here, we look at the triangle like this. So let this be our equilateral triangle of side 2 units. And the property of an equilateral triangle is that all the sides are equal. So the sides are equal to 2 units. So each of the sides here is 2, 2. And also another property is that all the angles are equal and each angle is 60 degrees. So all the angles are equal to 60 degrees. This angle too is 60 degrees. Well, because we are calculating the height, so when we draw the height from the top here, the height touch the base. And this height will divide this angle up here into 2. So 60 will be split into 2. That's 30 degrees. And also 30 degrees here. And it will meet at angle 90 degrees with this horizontal. And also this side, which is 2 units, it will be divided by 2. That's 1, 1 now. Then we now have 2 similar right angle triangles from here. And when we look at this, is a special triangle under trigonometry. So if you are familiar with this very well, you just pick the answer here without solving. And when we look into the solution now, we can pick any right angle triangle from here. So when we pick a right angle triangle, pick any one from the 2. We have angle 60 degrees here. We have angle 30 degrees. We have this side as 2, this side as 1. And this is the height we are finding. Let's call it x. And when we apply Pythagoras theorem to this, x squared will now be given as 2 squared minus 1 squared. That's Pythagoras theorem applied there. That means x squared will now be equals to 2 squared, that's 4, minus 1 squared, that's 1. And that's x squared equals to 3. So to get x, take the square root of both sides. X will now be equals to square root of 3. So that is the solution, and therefore the correct option from here is option A, root 3 centimeters. You are stopping at this place for today. You can subscribe to this channel so as to receive notification to any of our videos. We shall continue from here in the next class. Thank you, and we'll say bye for now.